In our previous examples, every circuit had only resistors and current sources. That made nodal analysis straightforward. Resistor currents are simply voltage over resistance, and current sources plug directly into KCL. Today, a new element appears, a voltage source. The question is, how does a voltage source affect the node method? Let's find out. Here is the circuit. A 1 milliamp current source on the left pushes current upward into the top node. 3 resistors connect that top node to the bottom ground rail. 1 kOhm on the left, 3 kOhms in the middle, and 2 kOhms on the right. But notice the right branch. The 2 kOhm resistor is in series with a 6-volt source, whose positive terminal sits at 6 volts above ground. This means the junction between the 2 kOhm resistor and the 6-volt source has a known voltage. It is simply 6 volts. So we still have only one unknown node at the top, which we call V1. V sub A is measured across the 1 kOhm resistor from V1 to ground. So V sub A equals V1. Our task: find V sub A. Let's write KCL at node V1. We sum all currents leaving through resistors and subtract the current entering from the source. The 1 kOhm branch carries V1 over 1K. The 3 kOhm branch carries V1 over 3K. The 2 kOhm branch, the far end is at 6 volts, so the current leaving V1 is V1 minus 6 over 2K. The 1 milliamp source enters V1, so we write minus 1M. Setting the sum to 0, V1 over 1K plus V1 over 3K plus V1 minus 6 over 2K minus 1M equals 0. To clear the denominators, multiply everything by 6K. We get 6V1 plus 2V1 plus 3 times V1 minus 6 equals 0. Combining, 11V1 minus 24 equals 0. So 11V1 equals 24. Dividing both sides by 11. V1 equals 24 over 11, which is approximately 2.182 volts. Since V sub A is measured from V1 to ground, V sub A equals V1, which is also 2.182 volts. Let's verify. V1 over 1K is about 2.18 milliamps. V1 over 3K is about 0.73 milliamps. V1 minus 6 over 2K is about negative 1.91 milliamps. Adding 2.18 plus 0.73 minus 1.91 equals 1 milliamp, which matches the source. Correct. Here is the key insight from this example. When a voltage source has one terminal connected to the reference node, ground, the other terminal's voltage is immediately known. It does not add an unknown. It actually reduces the number of unknowns. But what happens when a voltage source sits between two non-reference nodes, where neither voltage is known? That creates a special structure called a supernode, and that is exactly what we will tackle in the next video.